All right, so welcome everybody to the final presentation of the year, right? This started as a summer project last summer, and now we are at the end of the academic year, end of May, and so the project continues, and there's still going to be some work that we continue over the summer, and then we will plan a new iteration of this program for next year, hoping to recruit a new class of students from Ukraine and have a new set of projects, but then also those of you who are continuing to work with us are welcome to stay. And then we already have some initial paper acceptances, which is really exciting. So we're going to present a paper at FACT, and Tanya and possibly also Nazar are going to be able to come. Yeah, and Tanya got her visa today.
Oh, amazing.
So they will actually come to FACT in Chicago and will visit NYU. So this is an incentive for all of you students to have papers accepted so that you can come and visit. And we also have another paper that we're hopeful about that is currently in revision at VLDB. So we'll talk about that. So let me just hand over to Tanya to run the show, please.
Okay, I just can give the opportunity to say something to Yaroslav, and we will start our presentations.
Hello, everyone. I'll not waste time for my words. So just want to thank Julia, you, Tanya, you for leading this project from NYU and UKU. It's a really great project. I talk about such initiative in several universities. They are really amazed about such possibilities. They also consider starting such courses or such collaboration. And so you really inspire people. Thank you for this. And I'm happy to listen about your research. Thank you.
And tell us also what you're wearing, Yaroslav. It's a Vyshyvanka, right?
Yeah, actually today is a Vyshyvanka day in Ukraine, although currently I am in Washington, D.C. And therefore it's even more important to wear Vyshyvanka here. I'll have a meeting soon in several universities, so I go as is to these meetings. So happy to be and feel myself Ukrainian even here. Yeah, and also, Yulia, I'll probably email you a bit afterward because I'll be in New York for a few hours and hopefully we can meet.
Let's meet. Yeah, it's glad that you're only here for a few hours. We could have hosted you for a little longer. Yeah, please send me an email so we can coordinate.
Yeah, sure. Thank you very much.
Okay, great.
Thank you. So let's start. Let's start from Denise. Are you ready?
Yeah. Can you hear me well?
Yep.
Yeah. Okay, great. So let's start. Actually, it's actually the same project which we started presenting and working during the last check-ins. That was, I think, 2 months ago. Slightly the title changed, but the idea is still the same. So it's an experimental framework for measuring model fairness and stability in the machine learning lifecycle. And two key parts here is experimental and ML lifecycle. And yeah, I'm going on this project with Julia and Fala. So next slide. So we already presented this diagram last time, but now we improved it slightly. So all these stages were also like previously. And in general, this is just whole ML lifecycle, which is split on 3 flows. It's data preparation, model development, and model serving. And in each of this flow, we have various stages like sampling, measurement, preprocesses, and so on. But last time we said that in each of this process, we can have various type of errors. But now we decided to classify this type of errors. So this purple arrows means exogenous data errors. So this means that this data errors appeared not inside responsibility of data scientists. For example, you're a data scientist in company, and you don't have access actually how to create data set. You have data in your company, and you don't have great influence on population, how to measure it, and so on and so on. You have just data set. So all these red errors are caused by this data scientists, could be free cost, and the purple are costs outside of his responsibilities. So it's like sampling error or measurement error or unseen data error. And please, next slide. Also, yeah, on the first bullet here, what I just stated, that we have two types of errors. First one is exogenous, and second one is endogenous. Exogenous, it's like outliers, mislabels, which are related to measurement stage, for example. And other is endogenous, like modeling, preprocessing errors, for example, like non-optimal like technique for null imputation. Actually, this is the foundation of this work and the main motivation, just to start thinking in that way. We could not find like this view in any other papers. We improved them based on several others, and now we like confident in it. So this is the first point of our motivation. Second point in our motivation is that it's very crucial to understand the impact of these exogenous data errors. So because we can like anticipate and mitigate various detrimental consequences of them. For example, in terms of fairness and stability, we already have various fairness enhancing interventions, yes. But the interesting thing here is that they are agnostic to errors. So there is no, there is just one work that started to do something, but not so great amount of experiments with that. So they started to like create relationships between various data errors and fairness enhancing interventions they can mitigate. It's like second interesting motivation for our work that we can use is to create relationships between data errors and various type of enhancing interventions. And third type of motivation is that it's also important to not only test your model on one test set. We have such stage as unseen data errors, so some errors could occur during model serving, and it's important also to conduct such model stress testing where we inject various type of errors in incremental order in your test sets and look how your model behaves not only in one state, but how it behaves progressively over time. And for some models, this change can be great, but for others, not so great. So it's also important part for testing. And next slide. So for that, we created our empirical approach, how to actually conduct such type of experiments. So it's very simple, actually. We take one data error, we inject it into our ML pipeline. Second, we run our ML pipeline several times to make more concrete results in terms of fairness and stability metrics. Also, we repeat this procedure with all error injectors we have in our framework called MLCF, we name it that in that way. And after that, we look at these visualizations, how models behave under various type of errors and various amount of these errors. And next slide. And our empirical approach is the foundation of our new framework. Actually, it's very higher way of thinking about various stages in ML pipeline. So on this diagram, it's quite similar to our view on ML pipeline. We also have three various flows. In each flow, we have stages where we make preprocessing, tuning, computation, and so on. The crux here is the second block in the data preparation stage is error injection. So we have four types of error injectors. So we can set up what is the percentage of rows you want to affect, what's the number of columns you want to affect, and what columns exactly what you want to affect. So you have such controlled environment where you can use these error injectors, add these errors into your data, run all pipeline. Our framework gives you some tools to do that, and we also have our library, we have our Virni. Without Virni, we could not even start this project. So it was very great step toward this path, conducting experiments with ML lifecycle. So it's the main part of the third flow when we measure various type of fairness and stability metrics. And next slide. So to start with some experiments here, we also created environment to create a huge amount of experiments. And with our MLCF, it's very easy, because now just to run the whole pipeline for another data set, I just need to plug in another data loader, and that's all. I just change data loader and start the whole pipeline. We already have created notebooks, so I really like how it looks like now. It's very fast, and it's very fast because of the two things. First, we run it's on NYU HPC cluster, and second, we save our results in MongoDB. So we have our data model. Our data model also is very complex, but we try to add everything what we need and create specific hierarchy of IDs for each stage that simplifies our visualizations. So in addition to just frameworks, we also have this experimental setup that help us to conduct great amount of experiments. And next slide. Yeah, so what, for example, type of experiments we can conduct? It's just the one experiment which I can present and have time to do that. It's related to the impact of missing values. So we just want to understand what is the impact of missing values on accuracy, stability, and fairness in overall and for respective groups. And second point here is that we inject various amount of random nulls here into test set. They are presented here. It's 0%, 5, 10, 20, 30, and 50. So this is percentages of affected rows with nulls. So in these rows, we have at least one null. And next bullet, we state what is the number of columns are affected with these nulls. And the last point state what models we just use for this experiments. And next slide, the main interesting part of this is visualizations. So here, what you can see, the upper visualization is for campus dataset, it's well known. And this is results after injecting various amounts of random nulls. So this plot shows fluctuations for accuracy and the fun metrics to measure prediction accuracy, and jitter and label stability to measure prediction stability. So what we can see here on the upper plot, we can see that the fluctuation of accuracy and the fun is higher than for jitter and label stability. Maybe for F1 it's maybe the most, it shows the highest this variability here. On the below plot, we can see this is the same picture, that fluctuation of accuracy and the fun is higher than jitter label stability. But next slide, we want to look not only into these fluctuations, we want to look at these trends here. And our plots can help us to understand not only fluctuations, but what is behavior and what are the trends for each type of error. So in general, just random nulls. On the left, we can see a plot for campus, on the right for tables income. And on the left plot, this for decision tree on campus. Here you can see 4 various metrics. Upper 2 metrics is F1 and the label stability. Based on the previous box plots, they show the highest variability F1 in prediction accuracy and label stability in prediction stability. And here we look at their trends, and we can see here that we have trends not only in overall, we have trends in subgroups also, but for label stability it's quite constant, what we also could saw based on variability from the box plot. And the below 2 plots show fairness metrics. Here we use equalized odds FPR and FNR, and they show results for 3 groups, race, sex, and sex race. And this results actually for campus. We already know them that in campus model is quite biased to sex and race. So these plots also show that actually based on this type of error, we don't have great impact on fairness on campus. But if you look on the right side on equalized odds FPR and FNR, we can see that for this green line for FPR, it decreases on 2%. But for FNR right plot, we can see that increases on 8%. This increase in 8% means that model became more biased towards the fact that how to say that in context of income, this means that like non-white females less likely to have annual income that is more than $50,000. So this means that to this specific type of bias, this non-white female become like less likely to have this type of income. So like actually that's all. I don't have a lot of time to present other results, but at least now suppose at least you can understand something behind that work which we already conducted. So do you have any questions for now?
Let's have questions later because we're already behind quite
a
bit. Yeah. Thank you, Denise.
Okay, you will have to reload the presentation. Yeah, thank you. Okay, so our project, this presentation will be concentrated on the progress that we have made most recently after the last progress update, but it will also cover the progress before that. Okay, so the next slide. Okay, so like a little project overview. What we are working, so like just to remind you what you're working on, we are working on creating a query generator that will allow us to test for different things. And one objective that we started in the first place to test for is that some queries in SQL are not equivalent because of the three-valued logic of SQL. For example, in a where clause, when you compare numbers, if you compare null to anything, you get an unknown value. This is the third value. This is like a true, false, or non-value, or the unknown value. And so this makes queries unequivalent, and we wanted to test for that, but for that we needed to generate random queries. Next slide. And so which were the requirements for the our query generator? So it had to be extensible, it had to be general, it had to be able to support multiple dialects, so that it has to be easy to modify, it had to be trainable, and it had to always produce valid queries. So these were the requirements for the query generator that we would have. And the approach is that when we to generate some code, we associate this code with a path in the graph. So here, schematically, you can see that I drew a path in the graph that corresponds to the query that you see above that. And so like some nuances of this design. So it has to be, one nuance is that it has to be both dynamic and constrainable. So in our graph, we introduced a concept that is called a functional subgraph. We can call, we can reuse a three-valued value in the code by calling the subgraph that generates true or false value, right? And we can call it in many parts of the code. And in many parts of the code, we want this subgraph to behave differently. And so this is how we create contextual dependence on which parts of the code we can generate depending on where we are in the graph right now. This I will show later. And this next thing is that it needs to be constrainable because like when we generated some earlier parts of code, it imposes constraints on the later parts of code. For example, we can't select an integer column if we select from a subquery with only strings. So I will explain now this in detail. Next slide. So what we're working, next slide. Okay, so what we were working on in the last time was that the problem is that our generator, it generates wrong query. So this is an example of a query it could have generated, right? This query selects from a subquery that selects from a table that contains only a string column, only one string column. And then from this subquery, this query selects this column, that single column, but compares it to a number because it is not constrained to that this column is a string. So basically, we are not constrained in the where clause as to what our relations in the from clause look like. So if the relation in the from clause contains a string query, for sure contains a string query, We cannot know that in the where clause. We are not constrained to that in the where clause, where we are generating the where clause, right? So the first from clause gets generated before the where clause. Next slide. And so, so the reason is, as we can see here, what I talked about is that one part of the code is not dependent on the other part of the code. And basically, the core reason behind this is the Markov chain that we kind of were basing our whole concept on. Of course, it's not a Markov chain, but like it's like the inspiration, right? So it stores no state information. So we only have the current state. And but in SQL, parts of code has complex dependencies. So we have to solve that, right? We have to account for these complex dependencies. Next slide. Also, like one other way that the code has complex dependencies is that, like, for example, when you generate the having clause of the select query, it is dependent on the group by clause, because you group by some things and you only can put them the things you put in group by to the having clause. Next slide. So like the solution to that is triggers. This is what we call them for currently. And two types of triggers. So the triggers, they can turn off nodes contextually, concerning the chain to produce only correct queries, right? And so contextually means depending on where we are in the code, but also like programmatically. So what was generated in the code? We will illustrate this earlier. Next slide. What was the contextual triggers, right? What they are. So for example, we right now are generating a limits on our query. So a limits on a query is when you select some values and you want only 3 values to appear. When you generate a limit, you want to generate a number, right? But this number cannot be a column because it cannot reference a column. You cannot have this in the limit expression. So you put in the calling node that wants to create a numeric type, you put a specific constraint, a specific modifier, a specific code, right? That constrains the subgraph that's being called that generates a numeric value to not ever generate a reference to a column, right? So we can put code on the calling node that calls a subgraph that generates a numeric type, that this subgraph should not generate a column, right? And this basically, it turns off a node in the subgraph as illustrated on the bottom right picture. Next slide.
Okay, Mikhailo, you are out of time. Just
okay.
to let you know, you have 7 minutes to go.
That's great. We have like 60% of the presentation left, but basically that's our progress for now. So
okay.
yeah, like 7 minutes is not a lot. 7 minutes is not a lot. Okay, so like to sum up, this just like I need 2 minutes to sum up like our progress. We advanced on the query generator. We started implementing the training of this query generator. We faced the problem that we need to have types in the query generator. The problem that we have types created the problem that we want to constrain our query so like the parts of query are dependent on each other in complex ways, which introduced new concepts into our algorithm. We also implemented the missing parts like the aggregate functions, and finally our generator was able to provide, and we talked about this earlier, some contributions into the community, because we use a parser and we generated queries that this parser couldn't parse, and we submitted pull requests to the parser's repository and reproved the parser that we use for the SQL queries. So this is in very short like what we did. Yeah, thank you.
Let's spend a couple of minutes, just maybe 2-3 minutes on questions for Mikhailo and for Denise, just so that there's a little bit of a discussion. Because if we leave it to the end, everybody will forget what they said.
Yeah, that's true.
Okay. Any questions for Denise, maybe?
So I have a question for Denise.
Okay.
Am I right that I'm just curious, on the side of the client, for example, am I right that if I think that I can have some errors in my data set, yes, for some percentage, I can use your approach and then as an output have some metrics that could be sensitive really to this percentage. Yeah.
You mean to find like in what stage or what is the type of error you have in your original data set, or what? Yeah.
I mean, for example, I just gathered some data, and I expect that I have some errors. For example, I'm not sure that like 15% of this data is good, for example. So I can use your approach, and then we'll give like an answer, like an output that some of the metrics could be like sensitive, as you showed. For example, for tables that FNR is sensitive, for example, it like
actually probably yes. For example, for random nulls, I definitely thought that they more affect accuracy than stability, and yes, and but actually that's what not the main like part of the work. Firstly we thought that okay, we can maybe create such setup in which we can use to understand what exact type of errors we have in our original data set. And after that, Julia says that we can have a huge number of various types of in your data set. And so it's very hard to do that. So firstly, we at least started to concentrate at least to make these relationships between like types of errors and model behavior. And probably maybe next steps will be in that way that you presented. But at least for now, there is no any work that states what is the behavior when you inject incrementally increased numbers of nulls or outliers in your data. What is the behavior or model? So at least we need to like concentrate here, and after that next step, maybe we will do that part. Yeah. Thanks for your question.
Okay, got it. Thank you so much.
Any questions for Mikhailo? Okay, so let's move to the next presentation then. Thanks.
Okay, that's our presentation. And Sandra, are you here?
Yeah, I'm here. Can you hear me?
Yeah.
Yeah, cool. So yeah, we are working with small data, and we still working with it. And we have a lot of work done already. And, for example, with PDA. So later my colleagues task problem faced, but also we get the original dataset and make some analysis of it, and we had some insights, for example, share insights, which is about age, and obviously most of the people who took the exams are after 17, 18 years old, but still there are some people who are younger and have 16 or 15 years. They're probably outliers, but it's very interesting since there are some participants who have 14 years old. Next slide. Yeah, and also many people from the older age, they also took these exams still after the school exam, but many people who want to go to universities from the older age, they also took these exams or just took this exam for them, but they have pretty good trend after each year, less and less participants each next age. Can you go next slide? Next slide. Yeah, and also it was very interesting to compare different test results. For example, the Ukrainian language, most people have better results, and the mathematics seems like to be a very hard test because most people see this slide. Many people have comparable Ukrainian language and other language also on their tests. Also, they didn't reach the test threshold, so mathematics seems to be a very hard. Next slide. And the most interesting results were that for proportionality analysis, take original features, practice features, and others, and compare them with test results. And yeah, here, for example, results which we have about sex. So female participants are generally affected results in such subjects as Ukrainian language, literature, history, biology, geography, English language. And in contrast, mathematics is better for male. But it was surprised. Some things were surprised. For example, girls take physics tests and significantly more girls take chemistry, biology, and language tests. Next slide. Yeah, and also we found some demographic insights which regions need to have more support, and definitely the Carpathian office needs some support because they have very large proportion of those people who threshold, and also which was very obvious from the beginning, not to be confirmed during our analysis. Urban participants from villages, they are more not village, they are more likely to reach score threshold than rural participants who are from village schools. They need more support than citizens. Next slide. Yeah, we also take a look at correlation between scores for different tests, and was the highest correlation in mathematics, physics, and also other test scores have correlation too. But for Spanish language, it's hard to have some results because it has some participants who take this test. But we can see that other tests have strong correlation. Next slide. Yeah, and some couple of random insights that physics, chemistry, biology, geography, and language tests have higher percentage of participants who do not come to tests than those who don't reach the score threshold for themselves register, but they don't come. And also about language tests, like besides those participants who have profile education in this language, they more likely pass the tests. So that's all about it.
Thank you. Yeah, and we can start like as a ML task, which we want to try. It was like classifications, regressions, and ranking. For classifications, we think that we can like predict if the students fail or pass the exams. With the regressions, like the score. But after this analysis, we find that we have some like big problem in the data. Next slide. Yeah, and yeah, this problem is that the data contains duplicates inputs with different output values, which allows you to predict only like the average or some median value of these groups. It's like in the examples, which you can see that it can be like different, like first three rows is like the same input, but the score is different. This is why the model like predict only the some average value. Also, the problem of this data sets for the predictive task, not the for the ranking, is that all attributes also categorical, and we tried like to create new data sets, and Tanya will talk more about this part.
Thank you. So we thought what we can do, like how we can improve our data set and work on the level of schools, as Nazar said, because we can say about output something really average according to some school. And we found the new data set, actually like education expenditure from Ministry of Finance in Ukraine. It's open data sets. Yeah, and from there we have information like according to the schools, about number of teachers that worked at that schools, even number of retired teachers who still work. We have such problem in Ukraine, number of employees, number of students and classes, and one of the most important that we have a budget expenditure, I mean a government one for the current year, and even plans for the next year, so we can compare like the plans with the results using different data sets from different years. Here I put the link like for this data set, and so for us it was a really great idea, and the only one question was how we can merge these two data sets, and we had two problems. First, we should aggregate on the level of schools, and Oля will tell about this, and I will tell about matching of naming of schools. So there are some obstacles. Okay, so the first one is that our Minister of Finance and the Ukrainian Center of Educational Quality, they use different databases for school naming. So they so we have some troubles to match them. And people who actually created these databases were really creative. They use like a lot of interesting ways how to put like Ukrainian language, and we have like one database have information about private and public schools, and the other has only about public schools, and actually some schools like change their names during the year, and that's why we have some problems with this, but still we managed to to match 77% programmatically, and then the other part we are going to do manually. But anyway, with this data, we can create great tasks for the government about expenditures for education, like in both way, like which schools need support and which schools need awards. Okay.
Yeah, so because we talked about that it is hard to distinguish different participants, we decided to create a data set that would contain information about schools by years. So we grouped this original data set, and what we get is important features about, for example, demographic information. We just took sex data about how many males and females were registered from each school. Also the profiles of classes like mathematical or biological or something like that, and languages in which they studied. Most of them are Ukrainian, but still we have others. Also test count is how many people from each school were registered for each test. And status, how many people from the school passed, failed, were absent, or their results were annullated. And about their balls, we have this absolute number, and also in 200 scale. We took statistics about minimum, maximum, average, and also percentiles. And language in which the test was taken. This is for non-language tests like math, biology, and so on. And the DPI level is for foreign languages tests. It is like standard or profile language level in which this test was taken.
Let's wrap up.
So we are out of time. Very sorry. So we can go, or maybe somebody have some question for us, or maybe later at the end.
Yeah, let's do it at the end. So because we want to.
At the end, okay. I'm so sorry.
Yeah, no problem.
They also want to speak.
Right, so that's me, and I'm a part of the Synergy project where we created a benchmark for testing the data synthesizers. And let's go on, please. Next slide. Most of my work was dedicated to adding an additional paper to the list of the already implemented papers, because the point of the benchmark is to show, or rather test, whether the findings or conclusions from various papers would still hold if the synthetic data sets would have been used. I was working on the paper which tested whether marital satisfaction helps to not kind of go from the stress to depression. Next slide, please. Along the way, I have created, and I'm also in the process right now of creating the instruction or the example of how someone could do that, because it's also possible for open source contributors to add their papers or any other papers to the benchmark such that it would become more robust. And also when I believe this would become the default tool, then researchers could be sure that the findings of their papers are also tested for synthesizers. Right, next slide, please. Not much to tell about this one. I also added a couple of minor improvements in general to the tool chain. Next one, please. Also, I worked on the continuous integration. That's not merged yet, but I proposed a couple of the improvements in terms of code quality checks, etc. But also I suggested a better, in my opinion, way of working with branches, etc., pull requests, such that the toolchain, which is already available via pip install, such that it would be updated there automatically. And I think that this approach would allow to reduce the number of errors which would go into the production. And also I refined a little bit as I said, I created an example of how one could add the paper, and I suggested that it could be more interactive using a Jupyter book with IPython files, such that people could see it not in the markdown format, but to have working code there as well. Next slide, please. Right, and last but not least, definitely, is that we now have a submission to LDB 2023. The reviews are good. Well, previous reviews for the previous conference were good as well, but I believe that I'd say that I'm rather optimistic on this one. The general idea of the paper, and I'm scared a little bit that Julia would correct me here, but the idea is to propose another way of comparing the data synthesizers on specific findings of specific papers, assuming that this metric would be more important in practical use cases. Next slide. I believe that's Q&A.
We have time for questions.
Do you use GitHub Actions as your CI, like for continuous integration in your repository? Yes.
Could you repeat that?
I mean, that's what do you use for enabling a continuous integration in your repository? It's like GitHub Actions, or what is the tool?
Yes, correct, precisely.
Mm-hmm. Okay.
So our last presentation. Thank you so much.
Yeah, can you hear me?
Yep.
Yeah.
Yeah, so our project is about social media content analysis, and in particular, we are looking how Facebook deletes posts about war in Ukrainian and in Russian media sphere. Next slide, please. So actually, next slide. So by this time we got almost 3 million posts collected. We do this through a CrowdTangle, and we have the database. Also, we are able to collect not only text posts but images, and with the data we have enough the data to analyze it, to find some deletions, and we plan to write a paper this summer and try to submit it somewhere in the autumn, and Boris will tell you exactly what we have.
Hopefully, yeah. So if we do like a one sentence quick recap of what we do is we collect the data from the Facebook posts, and we kind of have two general ways of looking at the data. One is one being engagement, where we can say, hey, so like these different types of posts have this specific arc of engagement and like engagement growth, where engagement being the sum of likes, comments, and shares on a post. And the second point of view on the data is on the actual content of the posts. So as Hannah mentioned, we can look at the text and at the media pictures of what's deleted. Next slide, please. So we'll start by looking at just high-level overview of like what engagement looks like. We observed the posts over the 7-day window, and we are able to build this engagement arcs by different categories. And by some of the categories as shown here, they're quite similar. So on the left, there is a verified account, and the arc is, I believe, is like a mean engagement for all the posts we've collected. And we can safely say that there isn't much difference between verified accounts on what the engagement arc looks like. Same as for the language of the post. Next slide, please. But here we can see in the right chart, we can see the difference between media types. So media type is basically what Facebook type the post is. So there are photos, videos, links, live videos, and statuses being posts, which are just text. And we can see that there's a difference between different arcs. On the y-axis, there is the percentage total. That's the percentage of the total engagement the post gets over its 7-day lifetime. And on the bottom, on the x-axis, there is this time step. And so we can say that on average, like on a mean scale, the videos are the slowest to get their engagement, while live videos, which are, we could say like short-lived because it's live for 1 or 2 hours or whatever, gets the engagement the fastest out of all the categories. The next slide, please. And we also kind of have the definition of virality. So we've decided to split all the posts we've collected into like 3 categories by virality. Categories being low, medium, and high. And our current definition of virality, which is subject to change, is absolute engagement. So like the absolute number of likes, comments, shares, whatever, and the slope of the arc. And we can say that the posts with high virality that get the most absolute engagement are kind of the slowest to get their engagement. And it kind of makes sense because you know, it takes more time for more people to like something. And there's also this interesting shape of arc for medium posts, which kind of developers strongly in some point where there's the inflection change. The next slide, please. We could also talk about the engagement in terms of prevented engagement, and prevented engagement is when a post gets removed either by Facebook or deleted by the author of the post. And we really have no way to distinguish between those two, unfortunately. But the idea is that if a post is deleted after, say, 5, 6, 7 days, whatever, most of its possible engagement has already occurred. And so for these categories, wherever there's a spike at 0.0, this means that a lot of posts have around 0 prevented engagement, which is, I wouldn't say bad, but this signifies that we don't observe much of like moderation going on. The next slide, please. And we can also talk about content which was removed. One of the part of content removal is page removals, and here's a plot of page removed by day for a month of March to April. And we can clearly see that there was a spike on March 29th where 37 pages got deleted. The next slide, please. And so we looked at the content of those pages and ensured 32 unverified pages from our media were taken down either by their admins or Facebook. Some of them were Ukrainian related, some of them are not. And the content that we've observed on those pages was like engagement bait, clickbait, celebrity gossip, or low quality content. And the next slide, please. I believe this is the example one. Yeah, so this is one example of the content that's removed, like that's engagement bait that says, oh, please like this picture. Next slide, please. And this is a clickbait example, which has a link to some random domain with some whatever news. The next slide, please. I believe this is the summary. Yeah, so like, so what? The idea is that once we look at the engagement, we can say that there isn't much moderation that we observe. And that there are different shapes of arcs per different categories of posts. And in terms of the removals, we can see like page removals on the large scale. Sometimes we see that there is clickbait and low quality content, which is typical of Facebook probably. Some of this content is removed, but we haven't observed any like no type of minority content. Yeah, so, and there's then the time for Q&A, which is next slide. And the idea is to kind of turn all of this into a paper over the course of summer, just kind of describing everything in more rigorous details.
I have one question regarding how do you collect data regarding videos? Is also exposed by API or?
So we don't collect videos, unfortunately. The reason this works is you get a post from the CrowdTangle API, which says it has media of this type, and they give you a link which expires after a certain amount of time, which points to the content. So what we do for the pictures is once we record the post in the database, we download the image to our Google bucket and store it there for an indefinite amount of time. Okay, and we don't do that for videos because it's just more time consuming and space consuming, obviously.
All right, great progress, everybody. Looks like all of these projects are leading to papers. There's a bachelor's thesis that Denise is going to defend soon, right, based on his work. So yeah, very happy to hear about the progress. And
I would like to say thank you to all of the mentors, all the teams that make it possible to work on such great researchers and here today, so great projects. Thank you so much.
Amazing.
Yeah. Thank you.
Yeah.
Thank you.
And we'll speak again soon. We'll be in
Yeah.
touch.
Bye.
Your plans. Bye.
Bye.
Thanks. Bye.
See ya.